Like any star, Betelgeuse will eventually exhaust its core fuel and start to change. It will begin to swell, eventually enveloping the orbits of Mercury and Venus, and come very close to Earth. The impending demise of Betelgeuse is unsettling news for scientists, but there's nothing that can be done about it since the massive star is on the verge of going supernova. Astronomers predict it could happen tomorrow, next month, or a few months from now. They don't know the exact date, but one thing is certain. The famous Betelgeuse has reached its end, and its death is about to impact our lives. What makes the Betelgeuse supernova so alarming? What would happen if this star exploded today, as scientists have forecasted? Join us on this fascinating journey as we explore these questions in today's video. NASA's chief has announced that Betelgeuse will explode as a supernova in 2024, and nothing can stop the impending disaster. The NASA chief has warned the world about the upcoming Betelgeuse supernova, which could alter the trajectory of our planet and life as we know it. The end of Betelgeuse is imminent. Like a terminally ill patient, Betelgeuse is nearing its demise. It's only a matter of time before the famous star explodes and ceases to exist. For decades, astronomers have been captivated by Betelgeuse, studying the star's features and its impending explosion. The feared event is about to unfold. Betelgeuse is one of the most remarkable stars in the Milky Way, and it has fascinated astronomers and stargazers for centuries. Astrophysicists have long been mesmerized by this reddish, semi-variable star, whose apparent magnitude ranges between 0.5 and 1.6. Compared to other stars, Betelgeuse stands out as a first-magnitude star with a broad range. Classical astronomers described Betelgeuse as an orange star. The Alexandrian mathematician, astrologer, astronomer, and geographer, who spent years studying Betelgeuse, provided one of the early descriptions of this red giant star. Interestingly, even Aboriginal groups in South Australia have shared oral tales of Betelgeuse's variable brightness for over 1,000 years. However, advancements in astronomy have given us a more accurate understanding of Betelgeuse and its characteristics. The red supergiant star is located in the constellation Orion and is one of the largest stars known. Red supergiant stars are among the most massive stars in the universe, with diameters ranging from 100 million to 1 billion kilometers, making them one of the Milky Way's wonders. If we were to place Betelgeuse next to the Sun, it would be 100 to 1,000 times wider than our Sun. Research indicates that a red giant star is a dying star in its final stages of evolution. Although similar to red giants, red supergiants arise when a star with more than 10 solar masses enters this phase. When a red supergiant runs out of fuel, it can no longer create the heat and pressure needed to support its weight, leading to collapse. Betelgeuse's impressive features include its brightness. It is the 10th brightest star in the night sky and the second brightest in its constellation, just behind Rigel. However, if viewed in near-infrared wavelengths, no other star would surpass Betelgeuse as the brightest in the night sky. The Sun's brightness diminishes significantly when compared to Betelgeuse's enormous size. The red supergiant's radius is 640 times that of the Sun. If we could magically place Betelgeuse at the center of our solar system, its surface would extend beyond the asteroid belt and engulf the orbits of Mercury, Venus, Earth, and Mars. Based on calculations made over the years, Betelgeuse's mass is estimated to be between 10 and 20 times that of the Sun. The most surprising discovery about this star is that it is approximately 600 light-years away from the Sun, meaning it is relatively close by cosmic standards. Astronomers were astonished to learn that Betelgeuse is less than 10 million years old, making it a young star compared to our ancient Sun, which is about 5 billion years old. Despite its youth, Betelgeuse's size far exceeds most stars in the universe. Although scientists have attempted to measure Betelgeuse's exact diameter, it remains challenging due to its pulsating nature, which causes its diameter to change over time. Additionally, Betelgeuse lacks a definable edge, as limb darkening causes the star's optical emissions to vary in color and decrease farther from the center. Furthermore, Betelgeuse is surrounded by a circumstellar envelope of ejected matter, complicating the definition of its photosphere. The star's apparent size also varies with the wavelength used for observation, and atmospheric twinkling further limits resolution from ground-based telescopes. Despite these challenges, scientists have provided estimates of Betelgeuse's diameter. Another puzzle posed by Betelgeuse is the complex dynamics of its extended atmosphere. Scientists understand that mass in galaxies is recycled as stars are formed and destroyed, but they have yet to fully explain how mass is lost. Exciting developments from studying Betelgeuse reveal that its large mass has contributed to its rapid evolution. Mathematically, a direct relationship exists between Betelgeuse's increasing mass and its evolution over millions of years. Betelgeuse's imminent death is expected to result in a supernova explosion at any moment. When astronomers first discovered Betelgeuse's impending supernova, the scientific community was on high alert. A supernova is a powerful and luminous explosion of a star, occurring during the final evolutionary stages of a massive star or when a white dwarf undergoes runaway nuclear fusion. The progenitor star would either collapse into a neutron star or black hole, or be completely destroyed to form a diffuse nebula. If Betelgeuse were to explode today, the peak optical luminosity of the supernova could rival that of an entire galaxy before fading over weeks or months. The event's sheer brightness would be either frightening or thrilling for its observers. An intriguing fact about Betelgeuse is that it is visible to the naked eye at night. However, researchers are puzzled by the fact that Betelgeuse is almost unobservable from the ground between May and August because it is too close to the sun. Betelgeuse is one of the 3 stars forming the Winter Triangle asterism and marks the center of the winter hexagon. From early January each year, the star rises in the east just after sunset, and by mid-March it is visible to almost every inhabited region on Earth except Antarctica, which lies south of 8 degrees latitude. On a typical night, once daylight fades and darkness sets in, Betelgeuse is visible among the stars. If Betelgeuse were to explode today, everyone would witness its aftermath. The explosion would be as visible as a 3D live-action movie. The supernova would appear as an exceptionally bright point of light in the sky, potentially casting shadows at night. For more than 3 months, Betelgeuse's supernova would shine as brightly as a half-moon, profoundly impacting life on Earth. Given that Betelgeuse is only 642 light-years away, it's essentially a close neighbor. There's no escaping the inevitable. We are bound to feel the effects of this massive explosion. Before delving deeper into the potential impacts of Betelgeuse's explosion, it's important to note that the star's brightness is not constant. This might be surprising to many, but it aligns with the fact that Betelgeuse is a pulsating semi-regular variable star, undergoing cycles of increasing and decreasing brightness due to changes in its temperature and size. In 2019, Villanova University's Richard Wasatanek, Edward Jinan, and amateur astronomer Thomas Calderwood first observed Betelgeuse's dimming, which initially seemed dreamlike due to its unprecedented nature. After conducting multiple tests, the scientists confirmed it was indeed real. They theorized that a coincidence of a normal 5.9-year light cycle minimum and a deeper-than-normal 425-day period caused the rare event. By late 2019, other hypotheses emerged, suggesting the dimming could have been caused by an eruption of gas or dust or fluctuations in the star's surface brightness. In early 2020, observations from the Hubble Space Telescope led scientists to hypothesize that the dimming resulted from a vast amount of superheated material ejected into space, cooling and forming a dust cloud that blocked light from about a quarter of the star's surface. The Hubble captured signs of dense, heated material moving through the star's atmosphere in September, October, and November, before other telescopes noted the significant dimming in December. By early January 2020, astronomers found Betelgeuse had dimmed by a factor of approximately 2.5, from magnitude 0.5 to 1.5. The situation worsened in February, as scientists reported the star was the least luminous and coolest in 25 years. The news sparked speculation about a potential supernova, which was supported by NASA's cautious stance. However, normalcy began to return when Betelgeuse's brightness stabilized around February 17, 2020, and the star showed signs of rebrightening by February 22, 2020. Further studies on February 24, 2020, suggested that large-grained circumstellar dust might have caused the dimming. Although the dimming episode seemed to be over, recent reports from NASA indicated Betelgeuse had started dimming again. The American Association of Variable Star Observers confirmed that Betelgeuse had dimmed by about 0.5 magnitudes since late January. This news, reported on March 14, 2024, has heightened anticipation about what comes next. While the fluctuation in Betelgeuse's brightness is notable, the real concern remains the star's imminent explosion. The thought of Betelgeuse's explosion and its potential impact on our planet has caused widespread panic, with speculations about the event's possible outcomes. However, astronomers have reassured us that life on Earth will remain unharmed. They have declassified files indicating that Betelgeuse's explosion could occur within 100,000 years, meaning it might be millennia before it happens. Despite this reassurance, some astronomers paint a grim picture of what a supernova could do to our planet. If Betelgeuse were to explode during our lifetime, its brilliance would surpass that of any star or planet, releasing energy comparable to the Sun's total output over its entire lifetime. This massive radiation, including gamma rays, X-rays, and cosmic rays, could have significant effects on Earth's environment, potentially damaging DNA, causing mutations, and increasing cancer risks. Nevertheless, studies suggest that not all outcomes are catastrophic. Astronomers believe Earth's atmosphere can shield us from most harmful radiation produced by the supernova. Therefore, contrary to fears, the impact on life might be minor. The increased brightness of the supernova could disrupt nocturnal animals that rely on darkness for hunting, navigation, and communication. For instance, owls, which depend on night vision, might struggle with the increased light, affecting their hunting and predator avoidance. Fireflies, which use bioluminescence to communicate, might also face difficulties due to the supernova's brightness interfering with their signals, potentially altering their behavior and mating patterns. The supernova's brightness might also affect local ecosystems. Increased light pollution could disrupt bird migration patterns and alter insect behavior, potentially upsetting the balance of ecosystems. Models evaluating the supernova's impact suggest it could cause changes in the ozone layer and affect climate temporarily. Aside from environmental effects, Betelgeuse's explosion will provide astronomers with a unique opportunity to study supernovae further and gain insights into the life cycles of massive stars. Hopefully, future stars will live up to Betelgeuse's legacy. For now, we can only wait and see what story the universe unfolds with Betelgeuse's supernova. However, by late February 2020, Betelgeuse's brightness began to stabilize and show signs of rebrightening. Studies on February 24, 2020, suggested that large-grained circumstellar dust might have caused the dimming. Although the dimming episode appeared to be over, recent reports from NASA indicated that Betelgeuse had begun dimming again. The American Association of Variable Star Observers confirmed that Betelgeuse had dimmed by about 0.5 magnitudes since late January. This news, reported on March 14, 2024, has heightened anticipation regarding the next developments. Despite the fluctuations in Betelgeuse's brightness, the primary concern remains the star's imminent explosion. The potential impact of Betelgeuse's supernova on Earth has sparked widespread concern and speculation about its possible outcomes. Astronomers, however, have reassured us that the explosion is unlikely to cause significant harm to life on Earth. Declassified files indicate that Betelgeuse's explosion could occur within 100,000 years, implying that it might be millennia before it actually happens. While this reassurance is somewhat comforting, some astronomers paint a grimmer picture of what a supernova could do to our planet. If Betelgeuse were to explode during our lifetime, its brilliance would far surpass that of any other star or planet, emitting energy comparable to the Sun's total output over its entire lifetime. This intense radiation, including gamma rays, X-rays, and cosmic rays, could significantly affect Earth's environment, potentially damaging DNA, causing mutations, and increasing cancer risks. Nonetheless, studies suggest that the atmosphere could shield us from most harmful radiation produced by the supernova. Thus, contrary to fears, the impact on life might be minimal. The increased brightness of the supernova could disrupt nocturnal animals that depend on darkness for hunting, navigation, and communication. For instance, owls, which rely on night vision, might struggle with the enhanced light, affecting their ability to hunt and avoid predators. Similarly, fireflies, which use bioluminescence to communicate, might face difficulties due to the supernova's brightness interfering with their signals, potentially altering their behavior and mating patterns. The supernova's brightness could also influence local ecosystems. Increased light pollution might disrupt bird migration patterns and alter insect behavior, potentially affecting the balance of ecosystems. Models assessing the supernova's impact suggest it could cause temporary changes in the ozone layer and climate. Despite these potential environmental effects, the explosion will provide astronomers with a unique opportunity to study supernovae in greater detail and gain valuable insights into the life cycles of massive stars. For now, we can only await the unfolding story of Betelgeuse's supernova and hope that future stellar phenomena live up to Betelgeuse's legendary status.